This assignment is for the week of April the 27th through May the 1st. Again, you are going to log in to Google Classroom with your JCPS email and password. Go into the Science Classroom, click on Classwork, scroll down to NTI Assignments Must Do, and click on April 27th through May 1st Science NTI Assignment. Here is the Google slide. Watch the video that I will post later, and then the Google form is your assignment. You may redo the Google form as many times as you need to score a 14 out of 14. Okay, it is a must. So, your lesson for this week. This is Investigation 3. Our focus question is, how are the properties of a wave related? So we've talked about what a wave is. A wave is a vibration caused by a disturbance. And you now know some of the properties: amplitude, frequency, wavelength, and speed. So let's review. A wave is a disturbance that travels through space and matter that transfers energy from one place to another, and they are a repeating pattern. Remember that waves transfer energy, not matter. The wave to the right is a transverse wave. On the following slides, we're going to look at a few of its properties. Amplitude is the distance between the resting point, the center line, to the crest of the wave or to the trough of a wave. So this arrow is pointing to the center line, which is also known as the rest position. And you can measure amplitude right here from the center line to the crest. You can also measure it from the center line to the trough. Wavelength is the distance between two congruent points. So you can measure a wavelength from crest to crest. You can also measure a wavelength from trough to trough. Frequency is the number of waves that pass a point in a given unit of time. We describe frequency by counting how many waves pass a certain point in 1 second. The unit for waves per second is hertz, or capital H lowercase z. If both of these waves are moving at the same speed, the blue wave would have a higher frequency. Wave speed is the distance covered by a wave in a certain amount of time. Wave speed is described as distance over time, just like how we describe the speed of cars. You mostly see wave speed as meters per second, or m/s. One way you can experience wave speed in action is during a thunderstorm. You will often hear the thunder a few seconds after lightning because the wave speed of lightning is far greater. Okay, here's your instructions for your lesson this week. Wave properties can be measured. They are predictable patterns because of relationships between the properties. So, on your Google form, you're going to be asked questions that you're going to answer using this wave model. The directions that you see here are also in the Google form. You're going to set your model to oscillate. You're going to set it to no end. You're going to turn on the ruler, turn on the timer. You're going to take the tension to high, take the damping all the way down to none, and you're going to set your amplitude at 0.5 centimeters and your frequency at 1.5 hertz. Here is the link to take you straight to this simulation. Everybody should be able to access this. If it asks you to log in, use your JCPS email and JCPS password. So you're going to use that simulation to fill this out. Here is the link again. you can copy this link and you can paste it in your browser. So you can copy it or you can click here. It doesn't matter. But here is where it's going to take you. Right here, if you have a username, don't forget to log in. So you can log in with your JCPS email and password. You're going to click play game. It's not really a game. So if you look back over here at your Google form, make sure you put your first and last name. Make sure you pick your group. I will have the correct groups here. You're going to answer this question using this picture. You're going to answer this question using this picture. Here are your directions for setting up the model. Okay, I'm going to show you right now, however. You're going to click oscillate. Actually, let's pause this. So oscillate, let's restart this. So make sure this is paused. No end. You can turn on your ruler, turn on your timer, take this to high, take the damping to none, change the amplitude to 0.5, and leave the frequency at 1.5. And then you can press play, okay? You're going to use this simulation to answer all of these questions. So you have to read the entire description here because there's a question here. You're going to record your answer and I'm going to give you some feedback. Some are multiple choice, some are short answer. Okay? This is worth 14 points. You must score a 14 out of 14 for me to mark this as completed. When you answer a question right, on some of the questions, I'm giving you some feedback. If you answer a question wrong, I'm also giving you feedback. You need to make sure that you read the feedback as it's going to be helpful to understanding what it is you are learning and doing in this simulation. If you have questions, you need to set up some office hours for me. I'm also going to attempt some live sessions where you all can pop in during a certain time frame to ask questions as well. The only problem is I can't have more than about 4 people during those pop-ins. So we'll play around with it, but I'm going to attempt that this next week. When you are finished with your Google form, when you're done with this, when you're done filling it out, there should be a submit button or a done button here. You also need to go back and make sure that in the classwork, there's a button here that says turn in. Press the turn in button, please, so I know that you're done. And then I'll give you feedback. And if you are done, I'll give you a 14 out of 14 and say that you're completed. Please let me know if you have any questions. And I will talk to you all soon.